Welcome to qnawire.
So now we're going to work on problem 60 from chapter 13. In this problem, we're dealing with solution preparation. So we want to make a specific volume and concentration of two different solids, two different ionic compounds. And so the question is, how much mass do we need for part A? And then for part B, it's dealing with dilution. So we're given volume and we're given concentration, and we need to know mass for part A. So in part A, we're given 365 milliliters, and we can convert this to liters because we need that to deal with the volume, to deal with molarity. So milliliters cancel in this part. Then if we multiply by concentration, the desired concentration, we have 8.55 times 10 to the negative 2, and that's molarity, or moles per liter. So now we have liters canceling. We now have moles. So what we want to know is mass. So to get mass, we need to multiply by molar mass. So 136.09 is the molecular weight of the compound we're working with, KH2PO4, or potassium phosphate. And so when we multiply by this molar mass, we cancel moles and we're left with grams. And the value that we have here is 4.25 grams. So to make this solution, we should add 4.25 grams of KH2PO4 to enough water to make 365 milliliters. So remember, for molarity, we're not dealing with volume of solvent, we're dealing with volume of solution. So if we added 365 milliliters of water to 4.25 grams, then we would be having a higher volume of solution. So we don't add 365 milliliters of water, we add enough water to make up 365 milliliters. So in part B, we're doing a dilution of a certain volume and concentration of NaOH to a certain volume of and concentration of NaOH from a certain concentration. So what we need is the initial volume, the concentrated volume. So we know our expression for dilution is concentration of the concentrated sample versus volume of the concentrated sample, and then versus the concentration of the diluted sample times the volume of the diluted sample. So what we want to calculate here is the volume of the concentrated sample. So we have M diluted, B diluted divided by M concentrated. So volume of the concentrated solution is going to equal 0.335 molarity, which is the target concentration, and the target volume is 465 milliliters. And the initial concentration is 1.25 molarity. So here, molarity cancels, and we're left with the milliliters. So even though we have mole per liter in as the concentration unit, that cancels, so we don't have to worry about the milliliters being here. All it means is that the value that we get out, which is 124.62, counting for significant figures, 125 milliliters. So we have milliliters as our final unit. So to answer the question, we would add 125 milliliters of this original 1.25 molar NaOH to enough water to make the final volume, 465 milliliters.